Hello, everyone. Welcome to the 10th question answer session. In this session, we are going to discuss about integration in NMR. So let's begin. Well, the question has been asked by Asma, and she wants to know how we can integrate the NMR peaks, the proton NMR peaks on the mestrenova software. Or literally, the question is, what is the thumb rule for integration? So let me tell you, there is no thumb rule for integration. Integration means the number of protons in one signal. So if you have, for example, five signals, each one may have one, two, three protons. And when you combine the integrations of all the signals, you get the total number of hydrogens in your molecule. Now, say NMR is one of the techniques used for structure elucidation, and there are other techniques as well which you can use, or which you can use for getting different information about the structure of a particular molecule. So all these techniques, they complement each other, and the information that you get from all the different types of techniques like mass spectrometry, IR, NMR, and UV visible spectroscopy, you combine them, you connect the dots, and you get the structure. All right. So in my previous video, you asked a question that why I set the integration or the integrals to 1 or 2 or 3, or is there any thumb rule for that? So again, there is no thumb rule. You can start with any number and you will get a result. Now that result, are you comfortable with it or not? Based on the information you already have, like for example, if you have the molecular formula from mass spectrometry, from high resolution mass spectrometry, and it shows that you have 20 hydrogens in your molecule, and the total integrals that you have calculated are 10. So it doesn't mean that the molecular mass or the molecular formula that you have obtained from HREIMS is wrong. Your molecule definitely has 20 hydrogens, but the integrals that you have selected shows half of the protons. So what you do is that you double the integrals. Like I did in my previous video, the link for which you can find up there, that you can change the integrals. You can set it to 1, 2, 3. So if you have set a particular integral and the total number of hydrogen is 10, which is half of the number of hydrogens that you can see that you got from the HREIMS. So what you do is that you double, or you set the integral of one of the signals double to the number, to the previous number, and you will see that the total number of hydrogens would be 20. Right? So that is one way to do it. Another way to do it, like if you don't have the molecular formula, so how would you know whether a signal shows 1 proton, 2 protons, or 3 protons? So it sometimes comes with background knowledge plus experience as well. Now, for example, you have this proton NMR spectrum, like the one in front of you. Now, I have not shown integrals to any of these signals. Now, I even don't know what is the molecular formula of this molecule. So how would I know which protons or which signals are for 1 protons, which is for 2 protons, and which is for 3 protons? We have signals in different regions, starting with this signal which shows the TMS. This is around 1.5 ppm. These two signals, these are at 3.89 and 4.04, and then we have these signals from 6 to 7.5 ppm, and then we have a signal here around 13 ppm. Now, what do these signals mean? So you must have a background knowledge of what these signals mean. Like, for example, this signal at 13 ppm, what does this show? Now you can see that the signal is quite intense. Usually you find the signal for carboxylic acid proton around 11 to 12 ppm. This is even beyond 12 ppm, and the signal is much sharper. So this might be a hydroxyl group that is hydrogen bonded. Now we don't know how many hydrogen bonded OH groups are there in the molecule, right? But we assume that we have one hydrogen bonded proton OH group in the molecule. So what we do is that we integrate it, and the computer, the software sets it at 1, right? And keeping this or taking this as 1, the software then helps you integrate the rest of the peaks as well, right? So what I do is that I integrate all of these. So here we are. Now we have integrated all the protons in the, or all the signals in our spectrum, right? So what we have now is that what we have done is that we have one OH group that is hydrogen bonded, and we have how many? 1, 2, 3, 4, and 5 aromatic protons, and then we have these two signals for 3 and 3 protons, and then we have this signal which shows an integration of 9. Okay, now I have left this signal as such, and this is the signal for the solvent, that is the CdCl3, so you don't need to integrate it. Now let's go back to what we were talking about. You have to have a little bit of background knowledge. So what we have done is that we started with the signal at 13, and we assume that we have one OH, right? And then we have these integrals. Now what if we say that we have two OH protons? Now first, let's count all of them. That is 3, 6, 7, 8, 9, 10, 11, and 12. So we have 12 hydrogens, right, in total. Now what does this mean? This means that your molecular formula should have 12 hydrogens in the molecule, right? What if it has 24 hydrogens? But your integrations tell us that there are 12 hydrogens. So what we do is that we set this at 2. So when you set this at 2, everything else is doubled. And now if you count the number of hydrogens, 2, 4, 6, that is 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then 6, 24. So now we have 24, double the number of hydrogens that we previously had, because we doubled integration. All right, so this is how you can choose integrals for your molecule. Now another way to do it, now this we started with this signal at 13. What if we start with these two signals? We have a signal at 3.89, and usually if you have a CH3 group next to oxygen, a methoxy group, then the signal appears above 3 ppm, that is 3.5, 3.6 ppm. So we have the signal here, and it is around 3.8 ppm. Now we can assume that this is a CH3. So what we do is that we adjust it to 3, and you can see that everything else changes according to this. And again, we have one hydrogen here. So if this is a CH3, this shows that we definitely have one hydrogen bonded OH and we do not have two hydrogen bonded OH groups. All right. Another prominent signal that you see in the molecule, most of them or some of them, are the aromatic protons. So you can assume that this signal that is present here around 5.97 ppm, this is an aromatic proton or an olefinic proton, and it's a single proton. So you can set it to 1 and everything else is set accordingly by the software itself. So this is how you can set integrals for your molecule. Uh, Again, there's no thumb rule, but you have to use your background knowledge or the information that you have from the HREI-MS spectrum. Right? I hope your question is answered. For the rest of the viewers, do send your questions on the email address given below. I'll be waiting for your questions. See you next Friday with new questions and new knowledge. Thank you so much for watching.